let's go ahead and start. I'm very happy to start the next installment of our seminar series in Industrial Engineering Department here at Yaşar University. Our guest today comes from Invent Analytics. Mustafa Şahin is the head of algorithms there in the company. Invent Analytics is a company based in Istanbul. They do business analytics, software as a service company that specializes in retail, merchandising, planning, inventory management, and supply chain management. Mustafa Şahin has more than 15 years of experience in enabling analytical solutions for a variety of companies using mathematical models and machine learning algorithms. He has a wide range of algorithm development expertise from Wall Street quantitative analysis to hyper-casual gaming, and recently, I'm guessing, in Invent Analytics in operations research. He has a Bachelor of Science degree from Bilkent University's Mathematics Department, a Master of Science in Financial Engineering from Stevens Institute, and a Mathematics Master of Science from Ohio State. And his main fields of expertise are data mining, replenishment, algorithm development. We are very happy and thankful for his attendance. And he's going to be giving a talk on Omni-AI for Omni-Retail. And I'm guessing he's going to present very interesting stuff that they have been doing at Invent Analytics for retail companies. Mustafa, the floor is yours. Thank you very much.
Thank you for the nice introduction. Let me just bring up my slides and then start. And thank you for inviting me to this series. I hope I can share my experience and give you some insights about what we are doing. Just want to make sure that you can see my slides and hear me. Can you confirm?
Yes, okay. Perfect.
So the title of my presentation would be Omni-AI for Omni-Retail. So Omni, as you know, is the omnipresence and being everywhere and every time. So retail industry is transitioning to Omni-Retail. Before the Omni-Retail, there were just, in the initial stage, there were just one channel. You go to the store, you pick up your merchandise and pay, and that would be the end of the transaction. Then with the advent of the internet and the mobiles, we see the multi-channel retail, which means that you could access the same options through the web page or a mobile phone or any other means. But in that multi-channel environment, the flow of the goods and the information was separated from the different channels. With the omni-channel retail, right now, all of the retailers are trying to unify the customer experience, and they would just want to present you with the same experience, same flow of the information, flow of the data, flow of the merchandises in a integrated fashion. So for that comes with its own challenges, of course, and we are trying to address them as a retail analytics firm. So our solutions are based on basically inventory optimization and price optimization. So basically we are mainly operation research areas on the supply chain analytics. And we are using the financial optimization theory and apply it to the retail analytics. As mentioned before, I have like extensive background in mathematics, and I have worked as a hedge fund quant in Wall Street for almost 10 years. So like I have a little bit financial exposure as well in that area. And we are applying that to the retail industry. What we are trying to do is we go to the A/B test. Like our founder is Professor Gülhan Kök. He's a operation research PhD from Wharton and from Duke. And he has taught at Wharton. Now he's a professor at Koç. This year he is in sabbatical on MIT. So we are basically a little bit, we focus on the proving that our results and implementation shows the claimed benefits. So we generally do the A/B split test with our system in live environments, and we show to our clients that we can generate a couple of points of profit improvement, and our solutions are tailor fit to our customers. That's some of the slides are from marketing materials, so I'm just gonna skip them, just mentioning. But this I want to mention, like RILA is Retail Industry Leaders Association. It's the biggest retail group in United States and hence the world. So their members are like Walmart's, Targets of the world, and they had supply chain innovation. We received the supply chain innovation award just before the pandemic started over there. So this selection was done by the votes of the retailers, and we were competing against the like driverless trucks, etc. So we are very proud of this award we have. That's why I'm just plugging that into my presentation as well. And this is our leaderboard leadership team. Like I mentioned about the Professor Kirk, he has a PhD from Wharton, and he taught at Duke for several years. Jerry Neklaba, he's had the CEO of a couple of Fortune 500 companies, and we have extensive board. We are a Turkish company, and our headquarters in Turkey, but we have an extensive sales force and the implementation team at United States. We have clients from US to Indonesia, so we are not serving just Turkish customers, and most of the problems and the cutting edge innovations are coming from our international clients as well. So what we are trying to do basically is we are trying to balance the two KPIs, which is prevalent in the retail industry. One of them is in stock or like availability. That's from the customer's eyes. When you go to the store, you want to see what you are looking for. And on the other hand, there is an inventory turns or the inventory cost, and that's on the eyes of the retailer. That's the huge chunk of money that's invested, and they just want to try to make more returns on that inventory. So we are trying to balance that two KPIs, and we need to do it for millions of product location combinations. And with the omni-retailers view, that combinations are quadrupled or even come 10 times the previous size. So for the omni customer, on top of that product location based KPI view, we have to look at the shipping options, whether it will be home delivery, store collections, or pickup points. Especially in US, you can pick your items from certain locations. Will it be paid shipment or free shipment? Is it going to be same day, next day, or a couple of days? Can your customer wait that long? Do you allow the split shipments if there is more than one item in the basket? Is it better for you to send it in two different shipments from two different locations, or do you want to consolidate them? And that requires a little bit extra wait time. And the return options that might come from the client. So those are the main challenges. In the current state of solutions, like everyone says that we are doing machine learning, automation. If you don't say that, you are not allowed to go in from the front door of any companies. Like everyone says that, and we are. But on top of that, we are distinguishing ourselves from approaching this problem as I mentioned in my first slide, as a financial problem, because that's most of the retailers are in this game to make more money, and their bottom line goal is making more profit, and that profit comes from, that extra incremental profit comes from really making the profit optimal solutions, thinking that every product store location is an investment choice, which has a return of selling that item and gaining the margin and cost of carrying that additional inventory. So all those little product location combinations can be thought of like investment options, like stocks or commodities, and you need to find the efficient frontier for that portfolio. And like, as I mentioned, a couple of selling market materials, we are not user dependent, we are calibrating them in a faster way, and our time to implementation is really quick. This goes back to my point about the moving the things from KPI domain to the financial domain, and from that generating the total profit. So we are trying to balance the lost sales or additional margin with the inventory holding costs and fulfillment costs for the Omni-Retailer fulfillment options. Our solution list goes on in different areas of the supply chain operations. Like we are, of course, we need to have a demand forecasting, and that demand forecasting is AI based. On top of that demand forecasting, we provide replenishment, markdown optimization, assortment optimization, and pricing related aspects. And one Omni-Retailer specific problem is Omni network design. With the increase of the omni-channel fulfillment options, some of the retailers are trying to change their existing supply chain network. This is not a continuous thing, but it has to be done a couple of times, especially in these periods that we are experiencing, that everything is changing constantly. So sometimes you need to develop hub stores which can fulfill the demand in the neighboring regions, etc. So Omni network design is something that's coming up more and more in the recent days as well. Our systems, basically, we are a software as a service company. So our solutions, we try to host them in the cloud servers. As I mentioned, like every day we are making millions of product store, product location based decisions. So that needs to scale pretty fast, and our solutions every day we need to turn the data on in couple of hours, because it's very tightly integrated to client's operational system. So it has to be quick, so we can span out hundreds of workers, chunk work the data on, and then spit out the results. So we have a huge historical database, which includes the transactional data as well as some additional data, weather information, and location-based, special days-based information as well. We integrate the daily data flow on top of that, and we also include, as I mentioned, like internal analysis, and I will mention like halo effect, substitution effect as well, based on that transactional data. We generate outlier detections, clusterings, etc. on top of that data structure, and then we serve our clients with whatever solution they are requiring for, like whether it's the replenishment or pricing or transfer optimization. In the omni-channel side of the business, inventory transactions has, as I mentioned, quadrupled or became almost tenfold. Like, these are a couple of different versions of the potential ways of flow of merchandise. BOPIS is buy online, pick in store. So in that scenario, there will be original store location and fulfilled store location. You need to forecast the demand, and you need to add that demand to the sometimes to the original store location, and sometimes to the whole network that goes on, ship to home, ship to store. These are all different flows, and every flow requires a different type of configuration and the modeling for the underlying demand profile. In the new retail world, as I mentioned, like there is a selling location, fulfillment location, delivery location, and the dates and the demand date and the sell date and the fulfillment date are all different. So you need to balance all those information, gather them, and then find the optimal location which will provide you the highest profit based on those constraints. As I mentioned, like all those constraints requires a demand forecasting at the end. Like all those different channels, flows are there. We are analyzing that to have a clear picture of where the demand is and where will it be, basically, in terms of the predicted side of the business. So we need to look at the store, SKU, the item, and the zip code or the region-based demand, and we are including like special days and automatic outlier detections, as well as the lost sale corrections to those models, and that drives our demand forecasting algorithms. In the real world, most of the retailers, like when your system, however complicated your system is, when you generate a data, clients wants to know where that number comes from. So that is like one of the hot topics in the retail world as well in the recent days, the explainable AI. Like your AI can generate a perfect number, but until you convince the user that this number is correct and you need to use it, most of the retailers and most of the users will be reluctant to implement it in the first run. So what we are trying to do is having an explainable AI and what if simulations. We are trying to break down our forecast in a understandable chunks, but this part of the demand is come from the base demand of the item, and this section is coming from that special day effect, but there is a promotion coming up in another item, so there is a little bit cannibalization going on as well. So once you divide your forecast in that understandable segments, it is easier to convince the user to put those numbers into their operational system. And like in our world, what we are doing is when we say the demand forecasting, you can think of rolling a three-dimensional dice in the world, like for product, location, and time. Like we need to address these three dimensions. So one product can sell much faster than another item, and the same item can sell in a different speeds in certain location versus a rural location versus urban ones, and the demand, especially we went through the November, as you know, like Black Fridays and the wondrous Fridays, etc. So the time dimension also affects the demand. So you need to consider all those aspects and we are not generating a single point estimate, but we are generating a probability distribution of the demand. There is for the first store, there is a high probability that the item will sell 4 units, but it can sell 3 or 5 or 6. There is a very little chance that there will be no sales because this item is selling probably quite regularly. So we need to get that demand profile, and our financial optimization logic relies on that demand profile, not just a single point estimate. If you just look at the point estimates, the first store can have 4, the second store can have 2 or 3 items, but we need to have that demand profile so that we can have incremental benefit from sending 1 more unit to the store 1 or store 2. In the old retail, like these are a couple recap of what the world was and what the world is right now. In the old retail, you had this is the multi-channel kind of way. You made the purchase in the store, it's fulfilled from the store and delivered to the store. Or like you made your purchase at home, it goes to DC, and from DC, it's delivered to your home. But in the new world, you can make the purchase from your mobile phone. It can be fulfilled from either directly to vendor or from store or from DC. Like that, those are options, and retailer has to choose the most profitable one for them. And you may want to deliver it to your home, or you may want to take it from the store, buy online in store, or you may want it to be shipped some pickup locations or curbside picking as well. So there are, as I mentioned, there are a strategical level which comes with the omni-channel network design, where you need to decide which stores can fulfill the online demand. Sometimes you want to restrict a store to access the online demand because there is a huge physical demand in the store, and if you allow the online demand to access that inventory, it can deplete it very fast, and you may, if that store can be your strategical flagship location, and you may want to keep a high in-stock visual merchandise at that location. So sometimes you want to restrict stores from accessing the online demand. For certain regions, you want to have hub stores or hub DCs to fulfill the demand in the upcoming neighboring regions, etc. That's in the strategical level. You need to decide how your network is configured. In the operational level, you need to decide how much inventory I need to keep at certain location for a certain period of time. That comes with the forecast, replenishment, markdown, etc. And finally, in the execution, in the omni-channel retailer, the execution is almost a real-time problem as well. Like once you have an order generated when you go to the website, when you or from the store as well, when you generate that demand has to be fulfilled from some place, and that has to be decided almost real-time fashion. So over there, you need the sales probabilities of the current inventory at the current location and all the other locations. So you need to make that financial decision based on that constraints. Okay, I'm just going to skip that. And in that operational aspects, there can be several factors. Do you want to allow the shipment to be split, or do you want to look at the in-store demand? If there is a high in-store demand, you don't want to deplete that store demand. Sometimes stores or the locations can decline the pick request. Like you send that demand to certain location, but they say that like we cannot fulfill that demand whether it's a data issue, whether it's a store operational issue or DC operational issue, etc. And there is also a shipment cost, whether the location, your shipment location is close to customer or far away from the customer. Based on all those criteria, you need to come up with an optimal fulfillment location in a, as I mentioned, in an almost real-time fashion. That real-time decision is also relies on the probabilistic demand forecasting. That's almost the same idea I went over. And like one approach to decide on the delivery options and its effect on the lost sales and the profit is from convenience to like the convenience to the customer to the cost aspect for the retailers. Like there are a bunch of like additional dimension as well, like product size is a big issue, like online delivery options, like you might not wanna have like bulky products to be delivered to the store collection, click and collect type of options. Like in the old retailer world, there were just single channel where the user interacted with the retailer and they see one inventory dedicated to that channel, whether it's the store or an online website. Over there, when your customer couldn't see that the item that they are looking for, you assume that they didn't go and they didn't buy that item, you incur a lost sales. That's a big issue for retailers. That's why one of the KPIs that we are trying to balance is lost sales, lost margins, etc. In the omni channel world, the customer can interact with the retailer in several different ways, whether it's a mobile phone, website, store, or any other way. And so that duplicates the probability of lost sales. Like the item might not be available at store, but you can give your customer an option to pick up from another store, or you can offer her that we can ship it to your home, even though we don't have it right now, we can ship it to your home. And that same thing can be done with the online visits, let's say. You can say that we can ship to your home in a couple of days, or if you choose this location and this option, we can ship it to in 4 or 5 days. So all those offerings that you provide to your customer comes with a probability of lost sales. The customer who is in urgent need of the item might not be happy with your option of 2-day delivery. They are used to getting everything in the same day delivery from Amazon, so they may wanna skip you and look for other retailers. So generating that lost sales and having a different probabilities for different options is as well complicating the issue on the other hand. So what we are doing is like we are in order to come up with that lost sales and the demand forecasting, we are using, like, as I mentioned, like we are using machine learning models, and we are generating hundreds of features for every store location combination that can give an insight into that specific item in that location. It can also learn from similar items. It can also learn from same item from different locations, its position, price position relative to the other items, etc. There are a couple of examples in this list. These are the couple of features we have in our models, and of like cannibalization is affecting customers. Broken assortment is something that's affecting basically the fashion retailers. Special days, as I mentioned, has a huge impact in the demand. Some stores are very elastic to the price changes, and some are not. We need to consider all those things, and our models are trained and learned based on this features. By the way, if you have any questions, you can interrupt me and ask me, or if you want, you can write your questions in the chat, and I can come back to them at the end of my presentation. And we are not just using a single model, like we are using a couple of different models. We are using neural networks as well as the regression based on models and time series based on models as well. Gradient boosting models are very common in these days, especially. So, and we are using these models and generating basically a smart model selection on top of that. So all those models are run every day, and based on the recent performance and the upcoming potential performance, because for a stable product, moving like time series models are generally stable and reasonably good. But if there is an upcoming promotion, you don't want to rely on the time series models. You want to have a model which has a feature that's has a feature importance in that promotion period or special day effect as well. So our smart model selection algorithm looks at the upcoming period for that store location combination and try to choose the best possible algorithm to implement the result. As I mentioned, Smart Leg is something we have developed internally. It's a time series model. LLTD is log linear time series decomposition. It's basically a time series model with several additional features. XGBoost is gradient boosting type of models that I mentioned. So for the high seasonal products, this is just one example. Smart Leg, since it is a smart leg, it looks at the seasonality and gives an importance to that. So majority of the selections come from smart leg, but even this, even for some items, time series decompositions works as well, good as well. And for certain portion, gradient boosting methods is fine. As I mentioned, like cannibalization is a big, or the halo effect is a big part of the demand forecasting issue. So if you make a promotion in a certain item, it can eat from the demand of similar items. So we are trying to estimate that as well and try to put that into our models. This is just one example from two different brands of the similar items. When you have a promotion for one of the items, the sales of that item skyrockets and it grabs from the demand of the second item. As I mentioned, like I talked about that explainable AI and having your solutions be understandable and convincible to the customers. And the loss save root cause is one of the tools that we use in this aspect as well. Like lost sales is, as I mentioned, like one of the top KPIs for most of the retailers. They don't want to lose any potential sales opportunity, but it happens. But you want to know why you lost that sales. There might be myriad of reasons. Most common reasons generally are there is not enough supply. So even though system generated recommended order, that order is not fulfilled from the vendor, whether they don't have the inventory or the logistical problems, especially these days, are very common in US, prevented that order to arrive at the store, the location at the desired time. And there can be other reasons, like there might be a transfer out of that location, even though there were enough inventory at the beginning. There were some in transactional. There was a transaction that transferred out that item from that location to some other location, and that reduced the inventory, available inventory in a certain location, and that caused the stock out and hence the lost sales. So giving those type of visibility to customers, make them let's say content, and make them easy, feel comfortable using those type of machine learning stuffs. Like sometimes retailers will be in a reluctant mode because they have been doing this business, especially like mid-level employees. Some of them have their whole job rely on that. They have been doing it in a certain way, and when you switch that, and when your models pick up something and they haven't seen before, they would be a little bit reluctant. But once you show them that we have arrived this number because of this and that, they are more convinced in using the solutions. And as I mentioned, like we are testing our results, and we are showing that our improvement is really there by almost a scientific, not almost, really a scientific way, since like we are splitting stores and the items into equal sets, and we are implementing in one set, we are using the R methodology, and the other set is used by the existing system, and we are showing that our system can generate more sales and reduce the lost sales. This is an example from one of our US customers with almost 3,000 stores. Here are two line graphs. As you can see, like before the test, two groups are almost identical. There is no, before the pilot kicks in, everything is identical. But once we turn on the system, two lines started to separate from each other. Top one is the orange one is invent, and one is the existing system. So here you are seeing the revenue. So our system is generating more revenue, and it's almost after the warm-up period, it's very stable. And this is also like we also do those calculations, but in this case, our calculations are tested and approved by an independent data audit company called APT. Like this is also a little bit market material, but it has some good points. That's why I kept that. Like, as I mentioned, our founder is a professor, so we rely on the science, and we are just making sure that there is one rule: we need to maximize the profit. That's in certain cases that maximized profit can be replaced with maximized revenue, but most of the cases it's maximized profit. So for that we are using hedge fund map. That's basically like efficient portfolio theory, as if you are familiar with that. Finding the demand profile of each and every store SKU location combination, and from that you estimate the risk profile and the return profile, and with that potential assets you are trying to maximize the return of that portfolio. And we are proving that return on investment in that A/B test and showing that it's a sustainable and it's a consistent gain, not just a temporary gain from the analysis. But that, like, those are basically part of it. Like, this is just our workforce. Like, we have like more than half of our workforce has either postgraduate degree. We have PhDs and PhD candidates in our workforce, and we are supporting our students to pursue their masters, especially. And this is just our head count and the age distribution. We are, if you exclude myself and a couple of directors and the founders, we are pretty young team, and for a technology company we have a good size of woman workforce as well. This is our hiring processes. What we are using in terms of the technology stack is we are basically using Spark, and PySpark is our main production tool. For the analysis, our data scientists are using Python or R or another language. Some of them prefer C as well. We have a couple of archaic people using C as well. And we are using Databricks for the platform. We are using Airflow for the data management and the flow of the processes, and for the UI and the related things we are using Tableau for the data visualizations, and SQL for the data management for small sizes. For the big ones we are using the Spark, Hadoop basically. So that's all. We have a couple of environmental and social commitments. I just want to mention that we are a financial company. So far I have talked about the profits and etc. This is because we are in the retail business, and our retailers are really driven by the profits. But as a company we have a social and environmental commitment. Professor Kirk, just recently his paper is chosen to be best OM paper, operation management paper award in renewable energy investment and carbon emissions. And for our customers, we have several TADEP, TÜBİTAK, and Technocent projects going on, and we have one of our TÜBİTAK funded project is related to CO2, carbon dioxide emissions and the food waste. And we are also donating to the charities. We have several grant scholarships, one for the Bilkent University. Our founder is from Bilkent, I am from Bilkent. So, and we are in the E2 Technocent. So we have also a grant for the E2 Industrial Department and Computer Science Department as well. So we are trying to help young talents wherever we see them. And those are all basically, these are just a couple of things. This is our team. So that's all from me. If you have any questions, I can try to answer.
Well, thank you very much, Mustafa Şahin, for the presentation. We actually might be even more interested in some of the stuff that you are basically doing. I do have myself some questions, but I'm going to open up the floor first to other people, see in case that there are any questions. The attendees are also now welcome to turn on their microphones and cameras if they want to, when asking the question. Okay. But let me go ahead and maybe start the roll. So this is, well, let me read the first question. We have a question from our, I think, former student. So the Onur Chopur is a former student of ours who's, I think, finished his master's degree maybe, but he has a question in the chat box. Can you see that, or do you want me to read it?
I don't think I see it. I don't.
Okay. Okay. So it says that he's in a loud environment and he apologizes for that. For demand forecasting, are you only using sales data itself or some other features? If so, do you have some common features for all different products or tailored features for different products? Finally, for the interpretable machine learning, are you considering the future importance?
Yeah, like for the first part of the question, like we have this is just a selection of our feature set. Like here we have probably 70 of them, but we have more than 300 feature set. So those features are coming from the item itself, basically item's location initially, then the item, and then the location, and on top of that we have similar items. Generally retailers have customer decision trees, etc., group their items in the certain buckets. Like if you go to a grocery store and you are trying to buy let's say a cooking oil, there is a brand aspect of it. There is a size, like if you are a single person living, you don't want to buy a 5 liters or a big chunk. So on all those different aspects are playing a role in our forecasting. We have different features for all those things. And for the second part, yeah, feature importance for the machine learning models. Feature importance is a big part of that explainable AI results, and we are using the like Shapley values as well. We are familiar with that.
Well, he might be, Onur is working on these kind of topics. As far as I know, he graduated from our department and then was working towards his Master of Science in Italy on machine learning. I do have a question on how you work. This is definitely very interesting. I understand that you went over some of the things that the company does, for example, starting with the demand forecasting, and then retail optimization at the strategic level and operational level and execution level. Then I understand data science is an important part of what you do, because you probably go on and to do the markdown optimization or campaigns or this and that. You use the data analysis quite significantly, I'm guessing. But you said something about no need to do the tuning, parameter tuning, that which seems very, very promising. And also you said something about continuous customization at no cost to the customer, at what Invent Analytics does. I learned this first from my PhD advisor, and he was saying that if something sounds too good to be true, it probably is. And that sounds too good to be true. And my question actually comes to this: if you're not, I think when you said like we have to do the demand profiling at different stores when we get a new job, which makes perfect sense, but to me, and you don't want to, you don't have to answer this if it's a commercial secret, but you need to be using some sort of maybe simulation model in the background to either test or to understand the behavior. And if you are doing so, do you have something on your own, or do you have a way of developing a simulation model fast enough for each of these solutions? Or
yeah, that's a good question. Like in the first part of your question, like endless parameter tuning, that's I think a little bit miscommunication from my side. Like in the old systems, generally users try to manipulate their existing systems with entering different values to their machines. So, but in the new world, in our system and in some other systems as well, like you don't have to manipulate everything. You just want to have a general guidelines, and most of that, like our models are doing hyperparameter tuning all the time. That's behind the curtains. Like the end user doesn't see it. He doesn't have to go and change anything. Like that hyperparameter tuning is done at the initialization stage, and every certain periods, like we have to recalibrate our models, but you don't have to go and you don't have to do it manually. You don't have to trigger anything. That's one side of the thing. Like parameter tuning is done, but it's not done by people. It's done by machines automatically. That's one side. Yeah. Otherwise, like you cannot use your pre-COVID models right now. Like we have recalibrated our models several times during the COVID period, like because that's unprecedented effect, and we have to do modifications in our models as well. For your second part of the questions, like we have developed in-house several simulation models. And generally, what we are doing is before we go to any A/B test, we internally test our systems in our end. So we are almost sure that we are gonna achieve the results we are promising our customers. So we are generating digital twin of our client, whether it be a omni-channel network design or the demand profile. We generate the digital twin, and we have a simulation environment which can run through either the historical backtest type of thing. Like as I mentioned, I am from the financial world. Like when we developed a model, we used to do it backtest in our models, and from that in those models, you have to put every single thing. You have to put the commissions as well. Sometimes your model works perfect, but you don't include the commissions, and you are making a bunch of trades. All those commissions eats your return. So you have to think all those things. And in our models, in our simulations, we put the potential delays due to harsh winter conditions as well. Like we have pretty complicated digital twin structure, and we run our simulations on top of that system that's developed in-house, and that's something we are very proud of. It's a commercial secret. Like sometimes we show that before we sign any contract, like we ask our big clients, if you can send us the data, we can run as if we were running your system in 2020, and show you what would happen if our system were in place, and compare it with your existing, what you have experienced so far. And so that generated a couple of sales for us. Look, that's a good, very distinguishing factor for us. And thank you for reminding me that. Like I skipped that part.
I actually didn't intend to remind. I was just curious because worked on. Part of my PhD work was something similar, but we used simulation there with our research group as well to show back then gap stores that sourcing from here and there, and the inventory management would actually be better if they used this kind of decision making. So at this point, I'm guessing there should be even more advanced models. Adalet Hocam, you have a question? Yes.
Yeah, it may be a naive question, but first of all, thank you for your presentation, Mr. Hode. Have you ever developed or studied on the problems in the manufacturing sector, especially referring to IoT or Industry 4?
As a company, no, and myself neither. So like I cannot say that. Like we have
Okay.
one CPG customer, but we are just providing an input to their production side. We are also helping them in their distribution and networks and distribution of their materials, replenishment of their production goods.
Thank you.
Are there any other questions from the audience? Well, Mustafa Şahin, thank you very much. I guess that's it. This has been very interesting, at least for me. And so we wish to see you again, maybe in person and in more detail in the future. And good luck with your studies. Thank you very much.
Thank you. Have a good day.
Teşekkürler Mustafa Bey.
Thank you. Teşekkürler hepinize.
İyi günler.
Tekrar teşekkürler katıldığınız için.